The differential is very often used in error estimation problems. We are looking at the equation dy equals f prime of x dx. And we stated this in terms of change. If x changes by dx, y changes by about dy. We can think of this change as an error. If x has an error of dx, y will be off by about dy. For example, the volume of a hemisphere is 4/6 pi r cubed, where r is the radius. Let's say you measure the radius with a ruler and find that the radius is 7.2 inches. Then the volume, according to this formula, is 4/6 times pi times 7.2 cubed equals 781.729 inches cubed. Now the issue here is that rulers, I mean the common variety ruler you'd get from a convenience store or something, are not that accurate. They have ticks every eighth of an inch or so. So the real radius is not exactly 7.2 inches. Hence, the real volume is not 781.729 inches cubed. But is the real volume close to this? And here's where we'd use the differential, which, since instead of x and y, we have r and v, is dv equals v prime times dr. And this dr is here understood to be an error, a measuring error, and this dv is the resulting error in the volume. Well, of course, you don't know your measuring error. If you knew exactly what your measuring error was, you could add or subtract it from this to get the real radius. But frequently, we have a good idea of what kind of measuring error we're looking at. A ruler is accurate up to about 1/8 of an inch. That's where the tick marks are. You can look at something and you can round it to the nearest 1/8 of an inch. So even if we don't know the exact error in the radius, we can approximate the worst case scenario. The volume has as its derivative, we use the power rule. This 4/6 pi is a constant. It will just stay up front. 2 pi r squared, and r, as we've measured it, is 7.2 inches. So 2 pi times 7.2 inches squared. And the error in the volume this causes, of course, this is just an approximation, but it's v prime dr, the product of this and this, which is 40.715 cubic inches. Is this a lot? Whether an error of 40.715 is large or not depends on the numbers at play. If you're looking at a planet-sized sphere, an error of 40.715 would be nothing. If you're looking at some tiny ball, such an error might be huge. We define the relative error, which is the error divided by the predicted predicted value. Let me find this. We predicted the volume to be this. Times 100. And this is about 5.2%. Although whether this is large or small still depends on the situation and what you need it for, but at least we have some idea. 5% doesn't seem to me to be too large.